Hi everyone, it's time for our first talk here on the Sunday of PyCon 2017. Our speaker today is Dave Forgac, who's going to be telling us how to share our code, Python packaging without complication. Please make him welcome.
Thanks, well done. Of course, the screen shut off. There we go. Okay, so before we get started, I just want to note that I'm covering a lot of topics briefly today. So I'll have the slides, notes, and some further reading at the URL here, and I'll have that up again at the end, so you don't have to catch it now. That'll be there at the end. So you write beautiful Python code, and if you think it'll be useful to others, you want to share it. And when you share it, you want to do it in a way that people know how to download it and use it. And you may even want to collaborate with other people to make your code better. So you have the code, you think, I want to share it. What do we need to do? So the first thing is we need to package the code and upload it to the package index. This allows people to download it and install it the way they expect via pip install. I said we want people to know how to use the code, so this means we need to have some documentation. Okay. And if we want to be able to collaborate with people to make this code better, we need to put it somewhere that they can access it, and this usually means source hosting like GitHub, Bitbucket, GitLab, something like that. And then we want to make sure that when people make changes, they don't break things, so we need tests. And we want the tests to run automatically so that we can see if any incoming changes break things. So we should set up continuous integration service for our tests. And we should have a license so that people know under what terms they can share the code and use the code. And then it's a good idea to have a contributing document so that people know about how they can help you improve the code. So this should include things like, should they open an issue first or just submit a pull request, and what kind of things you want help with for this project. Okay, so we want to share the code, and already we have this list of things that we need. So you may be thinking that setting up all of this sounds like a lot of work, and it really would be, but it's not quite. So if you take just one thing away from this talk, I hope it's this. Because someone's already done a lot of the work to get these things set up for you. So use a tool like CookieCutter. CookieCutter is a tool that helps you make new projects from existing templates. Templates exist for all kinds of different projects, not even all just Python, but there are some really good ones for developing Python packages. And I have one of the good defaults linked with the notes. So my recommendation is to start from one of these already developed templates and make fork the project and update it with your preferences, like if you're using different services, different test frameworks, and things like that. And then you can make all of your new projects based on this template. Okay, so before we go any further, I want to go over a little bit of terminology just to make sure that we're using the same language. So module is just Python code stored in a file so that it can be imported. An import package is a directory structure for storing Python modules. And then a distribution package is where you bundle up your code and share it with other people so that they can install it. So this talk is about sharing your code. So for the rest of the talk, if I just say package or Python package, I'm referring to distribution packages unless I say otherwise. Now, of course, to make things more complex, there are multiple types of distribution packages. There's a source distribution. So this is what it sounds like. It's the source code for your application. And it includes extension source if you have extensions in other languages like C. So when you install a source distribution, all these extensions are compiled at install time. So then another type is a built distribution. And these are built or compiled beforehand so that they just need to be unpacked at install time. You may have seen reference to eggs. This is an older format of built distribution, and there's a couple other older ones. But wheel is the current built distribution format, and you should be making them for your projects. For a while, the package index only supported uploading wheels for Windows and Mac, but more recently, the Many Linux platform tag was developed, which defines a lowest common denominator interface for Linux systems. So this allows you to make a wheel that will work on most modern Linux systems. So of course, there are multiple types of wheels. So let's talk about those real quick. There's a universal wheel, and this is one that contains only Python code and is compatible with Python 2 and 3. So this can be installed anywhere, so that's why it's called a universal wheel. Then there's the pure Python wheel, and this is one that is specific to either 2 or 3, but it's still only Python code. And then there's the platform wheel. And so these are files that contain all the compiled code for a specific target platform. And so you need to build one for every platform you wish to support. Okay, so this is going to be the really short version of packaging history. So the packaging ecosystem grew organically for a long time. And for a while, it wasn't clear what was considered best practice. If you searched online, you'd find a lot of conflicting information about how to do these things, and almost always with a really strong opinion. So the way I went about packaging was I found a project that seemed like they knew what they were doing, and I copied the code, copied their settings, replaced the code with mine, searched and replaced the name, and released the package. But I never really understood what was going on, and I wasn't sure that I was doing things the right way. Then in 2011, the Python Packaging Authority working group was created, and it took over the maintenance of core packaging tools, and they've since worked on making some really great improvements to this packaging ecosystem. And one of the, besides the tooling and the specifications, one of the big improvements is that they took over maintainership of the Python Packaging User Guide. So now there's a guide that gives you authoritative information for how you should build Python packages. And so the rest of this talk tries to show you how you can build a package following that guide. Okay, so let's go ahead and make a new package. So we're going to be using CookieCutter, and the way CookieCutter works is you just provide it with a template. It can be a location on disk or a GitHub repo. It will prompt you for some just general information about the package or the project you want to build, and then it generates a directory structure customized with your input. This is the layout of a very minimal Python package. So most templates are going to have a lot more than this, but this is kind of the bare minimum. So the first part is your code. The CookieCutter template made a directory for the code, and then we put our code in that directory. A really common pattern is to store the code in an import package with the same name as the project. Now, the most important file for the packaging and distribution is the setup.py. This contains information that's used during installation and by the package index so that it knows about what this code is doing. It is just a Python file, so you can do fancy things in it, but you shouldn't. So don't be clever here. Just follow the minimum that is already provided in the template. Setup.cfg is a configuration file that often goes along with the setup.py. And it usually has settings for building and packaging plugins. So wheel is the most common thing that you'll see settings for here. And then if you have like test frameworks and things like that, you can also store settings there. By default, your Python code will be included when you build a distribution package. But if you have any other non-Python files that need to be included when the thing's installed, they need to be listed in this manifest file called manifest.in. This is typically used for things like data files, configuration, and documentation. And then finally, we have a README file. And this is what people see when they browse your project on source hosting. It's also commonly used as the long description on the packaging index. So this should contain general information about what your code does, basic usage instructions, and then where to find more information, like a link to your documentation. OK, so let's look at the setup.py. The first thing it does is it imports setup and optionally this helper called find packages from setup tools. And then all of the packaging configuration is provided as arguments to this setup function. Here there's just basic packaging meta information like the name, the version, descriptions, info about the author, stuff like that. And then you define which packages should be included in this distribution. These can be listed manually, or you can use this find package helper, which will discover any packages, any import packages that are in the directory structure. And then you pass names of directories that should not be included. So if you don't want the docs or the tests to be in the installation, you can exclude those. Install requires is what's used to determine the dependencies of your package at install time. So when you pip install the package, things listed here will get installed before your package gets installed. Note that this is different than requirements.txt. We'll look at that briefly in a moment, but I've linked to a page that would take a half hour to read that explains the details between requirements.txt and install requires. So go ahead and check that out. And then the package data allows you to define extra files that will get included in your package. And when you use this directive, it exposes it to your code via the name on the left so that you don't have to worry about calculating the path at runtime. So in your application, you can just reference, in this case, sample, and it would know where to find this package data file. Okay, moving down the setup.py. Entry points define interfaces, and so this is commonly used for defining plugins, but there's a special type of entry point called console scripts. So this creates a command that maps from the name on the left to the Python code on the right. It's good to use this instead of just including binary scripts in your, or executable scripts in your package, because it's going to do the right thing depending on the installation platform. So on Linux and Mac, it's going to create a small wrapper script, in this case called hello, that's going to map to that code. And on Windows, it's going to create a small exe file that will know how to find the right Python interpreter and where to find your code. Here we can define the license, so we can tell people what license the code is released under. And then we have what are called trove classifiers. And so these expose information about your package, and really commonly it's used to indicate what versions of Python you intend to support. Just note that nothing actually uses these values right now. It's just saying, advertising that, yeah, I intend to support 2.7 and 3.4, 3.5, 3.6. Okay, the setup.cfg file is just an ini style configuration. It has settings for your build plugins. So in this case, a setting for wheel telling the build system that this is a universal wheel. And it can include settings for things like flake8 and tests. The manifest.in allows you to explicitly include or exclude files or directories from the package that gets built. And then the README is typically written in the restructured text format, and it should include the basic information about the package. And like I said, it should include a link to where your documentation lives. In addition to listing the license in the setup.py, you should also have a separate license file just to make it really clear the terms under which you're releasing the code. You should really copy one of the common open source licenses unless your lawyer tells you to do otherwise. So again, that's another place. Don't try to get clever. You should have tests. Now, even if this is just an experimental project, you really should have at least a test that goes over the most basic use case of your program. And then if you're looking to improve coverage, you might want to note that in your contributing instructions, that you're looking for help with test coverage. But people are a lot more likely to help you expand upon existing tests than they are to just create them for you from scratch. So your template should include a test directory with some stubs and then a configuration for running the tests using a tool like Tox. You should, again, like the tests, you should have at least minimal documentation. One of the good things about using these templates is they'll build out a really good documentation structure for you, and you just need to fill in some details. And again, people are a lot more likely to help you expand on documentation than they are to just create documentation for your project wholesale. So at minimum, you should at least start with usage information. And then our template's going to include configuration for continuous integration. So the most common one for open source projects right now is Travis, but there are others. So it doesn't matter which one you use, but the configuration for this should live in your template so that it gets generated automatically. And then the requirements.txt file. Now this serves a different purpose than install requires, like I said. And there's a really good post with the differences. But this is generally used for developers of your project to install the exact version of the dependencies that you're using. There's a great tool for managing the requirements.txt called pip tools. So I suggest looking into that to help you manage these things. And then also really common, you'll have files that go over the history of the project, like history, changes, or changelog. You can have a contributing document to thank people who made contributions, or have an author's document. Okay, so let's go ahead and share this code. So we're going to use Git. We already created the package with CookieCutter. We're going to add the code and commit it. We're going to run our Tox tests and see that it passes in the environments we intend to support. That was out of order. So now we're going to go ahead and set up the services that are going to support this project. So the first thing is we're going to create a repository on source code hosting like GitHub. And then we'll go over to the continuous integration and add our repository there. So with Travis, you sign in with your GitHub account and click sync, and then enable the continuous integration for your new repository. They also have a command line tool if you're going to be doing this commonly that makes that process a little faster. So then you go ahead and push your code up to GitHub. And then a couple moments later, when you log into Travis, you'll see your tests are succeeding. And so now you already have continuous integration. So the next thing you should do is set up your documentation hosting. Read the docs is a great service for this. But if you don't want to do that, you could also use something like GitHub Pages. So you create an account and log in, and you point it at your repo, similarly to how you did with Travis. And then you basically click build, and a few moments later, you're going to have the documentation for your project already built out. Then you need to create an account on the package index. So this is at pypi.python.org. And this is what you use to upload and share your packages. And there's a little known copy of the package index called test PyPI that you can use when you're experimenting. So if you just want to test the package upload and releasing process, use test PyPI. It has a different set of credentials, but this way you're not adding more junk to the real index. So then you save your settings in your home directory in a .pypirc file. This saves you from having to specify them every time you run the commands. You may or may not want to save the password in this file, though. If you don't, the commands will prompt you for a password every time you use them. So for the rest of this, you should be working in virtualenv, and there's two great tools for managing virtualenvs. One's called Pew, the other one's called virtualenv wrapper. I suggest finding which one you like and using it. So then once you have your virtual env created, we need to install our packaging tools. You may need to install Wheel, depending on the version of Python you have and the environment. And then you'll install Twine, and Twine is a tool for uploading these packages to the index. And then we build the distribution files. And so you run the setup.py with the sdist command to build the source distribution, or the bdist wheel command to make wheels. Or if you're using one of the templates, they already include a make file, so you can just type make dist, and it will make all these files. And so when these are generated, it puts them in a subdirectory of your project called dist. So then you use Twine to upload them to the package index. And again, the make file also includes commands for doing the uploading. So something to note here is don't use the built-in setup.py upload command, because that's actually insecure. But it's being kept there for backward compatibility purposes. So use Twine to do your uploading. So now you should be able to install your package via pip. It's already on the index, so you can pip install just with the package name. And then when you're going to continue doing development, you can install your package in develop mode. And so that's done with setup.py develop or pip install -e, the current directory you're in. And what this will do is it will install the package and its dependencies in your current virtual environment, but then any changes you make are reflected immediately without having to reinstall the package. So this is really great for doing development. Just note that if you make changes to the entry points, you're going to need to reinstall because it needs to remake things like those wrappers. Okay, and then once you do that, you continue changing your code, you update the version, you commit, you run tests, you make sure the continuous integration is still passing, you build the distribution files, and you upload the new version to the package index. So one more set of tools that helps you with this part of the process is things that help you with the version and the releasing. There's two that take different approaches, and I've used them both in different situations. One's called bump version, which allows you to kind of drive the version number changes. And the other one is called versioneer, that allows you to control the versions based on your source control tags. But either way, I'd suggest using one of those to make the releasing a new version process easier. And then just to recap, so don't do this stuff by yourself. Someone's already made templates for everything. So there's really no reason to go off on your own. Take the time to set up the tools that will make your life easier in the long run. And then go ahead and share your code so that other people can benefit from the cool stuff you do. Thank you very much.
Right, if you have any questions for Dave, there's a microphone here in the middle of the room. We'll just give you a couple of minutes to see who we've got here. Yeah, first question.
Yeah, sorry, I thought there was a microphone over there. Yeah, I had a question. Is there anything that is like CI for build where I can like have my build and deploy process done sort of automatically with some sort of assertions, so that, because I'm just terrified every time I publish anything, no matter how much I've tested it locally, I'm just like, this is not formalized enough.
Yeah, so there are configurations for doing this with the same CI that you use to run just the tests. So there's a process for defining a Travis configuration. So you can do this via Travis or one of the other, like Jenkins or Circle CI or anything like that. So yeah, you can definitely have a separate task for that.
Next question.
Hi there, I'm still pretty new at this. Is there a preference to putting the list of files in manifests versus using the packages option in setup.py?
So the packages is specifically for the Python import packages. The manifest is for everything that's not a Python import package. So anything else like documentation and configs.
Next.
Yeah, you mentioned there was an option with setup tools, the develop mode. So in the past, what I've done for testing is you do that nasty shim thing where you have like a context and it changes the relative import path and actually imports from the source code for pure Python files. What does it actually do when it's running in develop mode?
As far as I know, all that it does is symlinks the directory that you're developing in to to your site packages. So it's like a pretty lightweight thing. But yeah, I have run into problems where you have to even reinstall in development mode if you change anything else about the environment.
And do you know if that plays well with like Tox or something, just for all the different virtual environments it's running in?
I'm sorry, I didn't hear that.
Does it play well with Tox as well if you're, trying it out in a bunch of different virtual environments?
Well, so Tox runs the tests in an isolated environment for each version of Python, so it's not connected to installing it in editable mode at all.
Okay, cool, thank you.
Next.
How are DLLs packaged and handled, and also how do you specify that, okay, this is really only for a Windows environment versus?
Honestly, I have no experience doing that, so I wouldn't be able to tell you. There may be some information in the Python packaging user guide about that, but I've just not experienced it.
Do you have any thoughts on using Docker Compose or Docker images to distribute packages?
Yeah, I have thoughts. What I really wanted to focus on here was specific to like the core Python ecosystem. There are other packaging ecosystems, both the like Conda and then like system repository packages. So that was kind of outside of the scope of the talk.
Thank you.
Yeah, just two more.
Is there a particular reason the readmes have to be in .rst instead of, for example, Markdown?
I'm sorry, I couldn't hear.
The README file, it has to be the .rst format?
So the README file actually does not have to be .rst, but the package index is looking for a .rst. So what you could do is have a different README file, so like a Markdown README file or just plain text, and then in your setup.py, you can load the contents of a different file. Some people use like a description.rst just for the package index.
I see, thank you.
Okay. Last question.
So this is all good for stuff you want to publish publicly, open source stuff up on GitHub. But for stuff that you want to, is for internal consumption only, what sort of stuff is available so I can, use pip install to deploy my stuff?
Yeah, so my recommendation is to follow the same process. And there's actually a trick. If you put an invalid trove classifier in that classifiers, it won't be allowed to be uploaded. So you can prevent it from being uploaded to the package index. And then there are a couple different repository hosting solutions. One's called DevPI that allows you to run your own local package index. But then there's also tools like Nexus that have plugins to allow you to do a Python package index.
Hey, and that's all the time we have. So everybody, please thank Dave Forgac. And we'll be getting underway here again at 1:50.